Assalamu alaikum everyone. Myself Aarez and today I'll be walking you through our Discrete Structures project. So this was a group project and I worked with my partners Ammad and Mudassir. So our project was basically on item level price co-movement networks using CPI data. The core idea of the project is that instead of looking at cities as nodes in a graph, we flipped it. We made the items the nodes. Two items get connected by an edge if a lot of cities show similar price movement patterns for both of them at the same time. The concepts used from discrete structures were relations, graph theory, cosine similarity, and centrality mechanics. So, if we move forward to the data collection and pre-processing, now the data situation was that honestly one of the harder parts. The PBS website has price data, but a lot of months were missing or incomplete in what we could directly pull. So we had to manually go through the website and gather all the missing data and compile it into a CSV. The methodology used by us was pretty simple. For example, in the first step, for each item and city combination, we computed a price change vector. In the next step, we computed cosine similarity between these vectors for every pair of items within a city. And in the next step, we aggregated across all the 17 cities. For the graph construction, we used the city counts and the graphs will be explained further on by my partners Ammad and Mudassir. So for the implementation, the programming language used by us was Python and I'll be explaining the code later on. The number of graphs produced by us were 9, which included complement graphs, weighted graphs, graphs of temporal analysis, heat maps, and threshold comparisons. So for the temporal and threshold analysis, looking at them, we found out that some item relationships are persistent, meaning they show up across all 3 years. Others are transient, which means they appear in just 1 year, maybe due to a seasonal shock or specific policy.
First graph is the centrality network for 2024. Each node is a commodity item. Node size shows degree centrality, how many items it co-moves with. Node color shows betweenness centrality, how often it acts as a bridge between other items. Bananas is the brightest yellow node, meaning it sits on the most shortest path in the network. It's the single most critical inflation transmitter in the 2024. Remove it and the network breaks apart. So in the graph 2, the second graph flips everything. This is the complement network. Edges exist where co-movement is absent. Items that were big hubs before, like bananas and mutton, become small here. Items like electricity and tea Lipton become the largest nodes because their prices move independently from almost everything else. Electricity is government regulated. Tea Lipton follows important prices, both march to their own rhythm. Moving to graph 3, the third graph shows connected components, group of nodes reachable from each other through edges. The result for 2024 is striking. Just one component containing all 49 items. Every commodity is connected to every other through some chain of co-movement relationships. This means inflation in Pakistan 2024 market is systematic. A price shock anywhere can theoretically travel everywhere. So further moving towards the fourth graph. Fourth graph is the cosine similarity heat map for top 20 items. Each cell shows the average similarity between two items across all 17 cities. The diagonal is always 1. Every item is perfectly similar to itself. Bright orange yellow cells above the white dashed threshold line at 0.5 are the pairs that got edges in the network. Mutton and beef score 0.75. Strong co-movements, same supply chain. LPG shows some dark blue. It moves against most food items, confirming it follows OGRA regulation, not market forces. Moving toward the fifth graph, the final graph is the sensitivity analysis test where our results hold if we change the cosine similarity threshold. The x-axis varies from 0.1 to 0.95. The y-axis counts edges. All the lines slope downward. Stricter thresholds mean fewer edges. The key finding: 2025 consistently has the most edges at every threshold level, meaning the most synchronized inflation year. 2024 has the fierce, most fragmented price behavior. Our chosen tau of 0.5, marked by the dashed line, sits at a balance point where the 3 years are clearly separated.
City threshold reduces a connection. At k is equal to 1, we have 800 edges to lose. At k, as k rises, each edge drops sharply. We by ourselves chose the k is equal to 3 as a sweet spot because it was more meaningful. You can note that the red line, which is of 2024, is always the lowest, confirming that the 2024 had the weakest co-moment. Next is the network graph. This is all 2024 price network. Each dot is an item. Each line means they co-move in at least 3 cities. Larger, brighter nodes like beef, mutton, and goat are the mostly connected. Their prices influence everything around them. Electricity sits isolated at top because its price is regulated by the government, so they are isolated. Now the Next one is uh, the weighted cosine network graph of 2024. Same network, it has same network as 2000 graph 3, same nodes, and it has same edges. Only difference is the edge is of edge thickness. Now shows strength of similarity instead of numbers.
Okay, so as I've already told you that Python is the programming language that we're going to use. Here are certain modules that I have imported which are necessary for the code, and all the explanation is given in the comments. So after reading the CSV file, we decided to use some colors to make our graphs look more attractive. And here are the functions that you can see which apply the color to the background and also to the nodes that are printed. So moving forward, here is our first function which is about the compute vectors. What this function does is that it groups data by item and city and sorts them by month. It computes monthly price changes and removes incomplete or flat data. The output is the vectors of all the price changes that we have, and it returns it. The next function is about the city similarity. For example, if you take one city and then compute its cosine similarity for all item pair and then return the similarity scores. The next function involves the building year of data. It processes 1 year, counts how many cities show co-movement, computes average similarity, and then the output is about the counter and the average cosine vectors. Moving forward to the build graph function, it creates graph from item pairs and adds edge if the co-movement is greater than or equal to the number of cities which is represented by k, and then we just return the value. For drawing the edges, we use this draw edge functions, which is used for drawing an edge with custom width and transparency that depends. So for the spring function, it just positions the nodes using force-directed layout, and data loading CSV loads the CSV and removes the missing values and builds all the yearly data sets that we need. So moving over to the graphs, the graph 1 is a complement network and shows items that do not move together. The next graph is about the weighted network, and its edge width is equal to the number of the cities, so it means if the edge is thicker, then we have stronger agreement across the cities. Moving forward to the third graph is about weighted cosine network edge with average similarity. It shows strength of relationship. The next graph involves centrality network, and it is usually measures the importance of items degree, like the number of connections, closeness, or distance to others betweenness. You can also call it bridge rule. The fifth graph is a very important graph and is related to the temporal analysis. It tracks centrality across years, uses group bar chart, and the next graph is about the sensitivity analysis. It tests different tau values, shows how graph destiny changes, and then we have also drawn a heat map. This heat map shows similarity between top items and is basically a matrix visualization. Thank you, and that's a wrap. Thanks for listening, and we're happy to take any questions.